All right, good evening, everyone. So let's power on to the last and final session. I'm sure this will be as interesting and impressive as other presentations as well. So let us start with the first presentation for this session from Ms. Riza Pineda. Thank you.
Good evening, everyone. My name is Riza Carmela Pineda from the Philippines, and I'll be presenting Local Fi, empowering communities in the Philippines with Wi-Fi to close the digital gap in the age of Industry 4.0. It's hard to ignore that it's already dark outside. It's 6:15 in the evening, and we are a bit tired, I know. But I do hope that you would still listen to my presentation, and I won't take much of your time, I promise. By definition, Industry 4.0 or 4.0 is characterized by the integration of technologies like IoT, AI, cloud computing, big data, and edge computing to create smart factories and environments. However, these technologies that I have mentioned require a, uh, a hardware, it requires an infrastructure that would now accommodate these technologies. For the case of the Philippines, we cannot fully embrace the Industry 4.0. We cannot fully adopt Industry 4.0 because of some roadblocks. I have identified the major top 3 roadblocks to Industry 4.0 adoption. First is digital divide or digital gap. You do need to understand that our country is an archipelago. There are communities which we consider as last mile, and these communities are not having any internet access. There is no modern software and devices, and they are being left behind in the adoption of these technologies. Also, there are insufficient or lack of infrastructure. These last mile communities have outdated or insufficient infrastructures, and they struggle in adopting Industry 4.0. And consequently, there is a skills gap because educational and training systems may not be keeping pace with these technological advancements. So our project, the Local Fi, serves as an enabler of Industry 4.0 or a catalyst of Industry 4.0. We aim to address these roadblocks by as follows. So first, we are aiming to bridge the digital gap. Local Fi provide connectivity to last mile communities. Local Fi could build cheap, affordable, community-operated Wi-Fi network or build infrastructures. And the Local Fi has an added feature, which is the on-premises apps. These applications are accessed freely by the community or by the users, and we provide online learning resources and platforms that offer courses in relevant technologies. In a nutshell, local Fi technology, or this is actually a word play of local Wi-Fi. So since we are serving last mile communities, we are providing community Wi-Fi network, and we dubbed it as Local Fi. So in a nutshell, Local Fi empowers last mile communities by bridging the digital gap with affordable community-operated Wi-Fi and free access to online learning resources, fostering innovation and growth in Industry 4.0. All right, so for our proposed method, for us to develop and deploy Local Fi network, there were 2 parts in our design. The first one is we identified our pilot sites. The way that we select our pilot sites is that there should be no internet service provider or any telecommunication network provider in the area. And how did we do that? We have a tool called Spectrum Analyzer. It's a handheld device, and we visited these last mile communities, and we conduct spectrum measurement. If we do not detect any signal or any presence of telecommunication or internet signals, then it would be, we would consider that last mile community as one of our pilot sites. Then for our system design, we divided it into 3 categories. The hardware, we implore commercial off-the-shelf components because we want our design to be as cheap and as affordable as possible. Then we focused our technology on the creation of a local Fi captive portal. The the image at the far right corner of our screen is our locally developed local Fi captive portal. So for this, our aim here is that we want our local Fi network to be sustainable, and it could be sustainable through our voucher system. So we could sell vouchers to our users, to the community, and that would generate income to sustain our technology, the local Fi network. We also used the MicroTik platform, which is called the MICMON, to generate vouchers and login credentials for the monitoring and user management. And lastly, the added feature of our design are the on-premises apps, or we can call it the locally cached content. So without any connection to the internet, for example, our user cannot afford or cannot buy at the moment a voucher, they can still access some applications through the local Fi network that could aid them in their learning or sometimes some information that are useful for the community. So by definition, on-premises apps are accessed locally even without an internet connection, and the edge server stores and distributes content within the LAN. My next slide would focus on the hardware. However, on the software, I cannot give more information because we are currently applying for an intellectual property, and giving you more information about it might compromise our IP filing. So let me share our hardware at the moment. It's very simple. We used commercial off-the-shelf components. We have an internet point of presence which connects to the internet, and it allows now data through the PFSense caching proxy to optimize bandwidth by storing frequently accessed data. Then we have the MicroTik router OS to manage the LAN, the local area network, and to connect to the local Fi network. And then for the access point, this is to distribute Wi-Fi through our local Fi network, and the Wi-Fi devices will connect now to the local Fi network through the access point. We have the content server, and the content server serves as a host of our locally cached content, and it is now responsible in generating voucher code, manage accounts, and set authentication bypass for our free sites. We have conducted some preliminary tests, field tests, in one of our sites. By the way, we have 4 sites. I will show you our sites later. So this is one of our pilot sites in the Philippines. It's a mountainous area in the Philippines, and using our access point, which is a WavLink, so that's the brand of our access point, we managed to have the network at a range of 450 meters. And we do need to understand that there is no correlation between the distance and upload or download speed, simply because of the following: the terrain, it's a mountainous area. There is a thick foliage because of the trees and other vegetation present in the area, and other obstructions. By the way, the height of our antenna is 12 meters. So it's actually just a community Wi-Fi network. All right. There are quite a few impact on our technology, but let me pick one of each category. For the scientific and technological impact, it could boost to IoT infrastructure, which is now a catalyst of, or would now enable Industry 4.0. For societal impact, it is sustainable through our voucher system. For collaborative, we can partner with different agencies or LGUs or other institutions for the on-premises apps. In fact, we have partnered in our country, we have partnered with Department of Education. We have locally hosted their educational videos. We have partnered with other schools or universities for their content, and we are planning to partner with the Technical Education and Skills Development Authority of our in our country. We have partnered also with our local government units for our pilot sites and the different regional offices of our department, the Department of Education, Department of Science and Technology. These are our pilot sites. We have local Fi network in 4 regions in our country, and well, surprisingly, since the terrain and the physical location of our sites, the behavior of our network differ from one location to another. We observed that in some areas, the 450-meter range in one of our pilot sites is not the same as the other because, again, of the terrain and the foliage and the other obstruction. What is our output? We have developed a community Wi-Fi network. We dubbed it as Local Fi. We have developed also a captive portal. This is what you will be directed to when you are connected to the Local Fi network. You can connect to the internet through the voucher, and you can also connect to the internet through any login credential. Now, as I mentioned a while ago, you can also access on-premises apps. These are free-to-access apps which are customizable depending on the need of the community. So we can provide some information or some apps that are needed by the community. Let me skip this. These are just the long-term output. In conclusion, the Local Fi is an enabler of Industry 4.0. The Local Fi aims to develop and deploy community Wi-Fi networks to empower our last-mile communities. Because our aim is to be inclusive. We don't want any community to be left behind. So we need our people to feel that they are involved and they are in the digital world. So for our implementation, we identified sites, we designed the hardware, the software, and the on-premises apps. For our future plan, we want to identify or develop a business model to strengthen the sustainability of our project. Because for now, we are only, internet is provided for free. We are actually dealing with different NGOs so that the internet is free. But again, that's not sustainable. We want it to be sustainable. So we want to develop a business model. And we want to expand the local network coverage. We only have one node now. We want to design a mesh or to expand by providing or establishing more nodes to expand the range of our Local Fi network. So allow me to mention also the other team members of Local Fi, Sir Philip, Sir Kenneth, and Sir Ramon. And Local Fi is part of a bigger project called RAIN, Resilient Education Information Infrastructure for the New Normal. I do understand that this forum encourages us to collaborate, so you can contact us through our social media platforms, and I am now open for any questions. Thank you.
All right. Thank you, Engineer Pineda. The floor is now open for some of your questions, please. For Dr. Ashley.
Okay, so thank you for your interesting presentation. I just want to clarify a bit. Like, is there any specific criteria for the offering Local Fi to the community? Is it just open for all, or specifically for the educational institute or school, something?
Good question. The primary objective of our project is for the education sector, but we are now expanding because we found out that our project benefits more than just the education sector. The whole community, in fact, in our 4 pilot sites, aside from the teachers, the other members of the community are benefiting from our project because the officials are now having meetings through Zoom and they're connecting to the local FI. So yeah, well, initially it's for education, but it could be expanded.
Okay, so I have another question. Just
Sure.
you mentioned about the bulk test for the signal coverage, but I just want to clarify that for the internet access, you may need to either access via the cellular system or the network or the ISP. So in terms of your project implementation, what is the way of supporting the internet access? Because you will need to pay for the bandwidth, and then you will need to offer it for free for the public. Is there any support behind your project implementation?
Yeah, so that's why I have mentioned here in our future plan, there is a need to develop a business model for the sustainability. For now, what we have for the current setup, it's given for free because we have funding, but of course that won't last forever. So we need to identify or develop a business model. We need to teach the community on how to generate income through our projects so that they could sustain or they could still operate without any help from the government.
Okay, I see. Thank you so much.
All right, any other question? There's another question.
Okay, thank you. You show the area, which is, you say this is one of the technical problem. It is mountainous and so on and so on. You say that you need some sort of business model to make sure that your local FI, yes, is sustainable. Now, my question is, given the fact that the local situations might be different from one place to another place, and that means that in one place maybe one satellite dish is enough, while in just another place, not only 400 meters, 450 meters cannot be achieved, maybe only 100 meters because so many mountains and so on and so on. And does it mean that you will have to develop a business model for all this type of area?
Yeah, that is really a challenge for us. We do understand that challenge, and there could be an issue about the business model because it's not one size fits for all business model. So we are teaming up with other agencies on how we could do this. In fact, we are partnering with USAID Beacon, if you are familiar with USAID Beacon, and they are assisting us on how to build the business model. We might, it's true, sir, we might have an issue on the business model. That business model might not be, one business model for this pilot site might not be applicable to other pilot sites. But we want to take that, we want to take note that we really need to think about that, sir.
All right, thank you. Unfortunately, time's is up. I'm sure Dr. Coirel there has the comments or questions as well. Let's give her another round of applause. Thank you. Now we move on to the next presentation from University Technology Brunei.
Okay, thank you, Chairperson. Assalamualaikum and good evening, everyone. We are almost at the end of today's program, maybe looking forward to the dinner. Okay, so my name is Najiba from University Technology Brunei, and I would like to share with all of you our proposal on aquaponics, more specifically enhancing aquaponics sustainability through IoT and predictive AI technology and analytics. So first of all, let me briefly explain what aquaponic is. So aquaponic is an agricultural practice that combines aquaculture and hydroponics to create a sustainable and symbiotic ecosystem. So in this system, the fish waste, as you see in the picture, it serves as a nutrient source for the plants, while the plants, they filter and purify the water for the animals. Okay, so this actually creates a closed loop cycle that minimizes the waste and also maximizes the resource efficiency. Okay, so this helps to conserve the water by recirculating within the system and making aquaponic a highly efficient method for food production. Okay, however, there are certain challenges remain in effectively managing the water quality as well as resource efficiency. So for the background of the problem, the first one is traditional systems. They often rely on manual monitoring, water monitoring quality parameters, which can lead to delays in identifying and addressing issues that affect both the animal as well as the plant's health. Okay, and then these systems, they lack predictive capabilities, making it difficult for the farmers to anticipate any changes in the water quality. And then this limitation can result in inefficient resource and also increase operational costs just to maintain the whole system. And then furthermore, controlling and maintaining the water quality suitable for both plant as well as the animal can definitely be a challenge. Okay, therefore, there is a need for comprehensive research on integration of IoT and AI technologies in aquaponics. So yeah, again, so these are the targets of the project. The first one is to design and implement a smart aquaponics system that integrates IoT technology for real-time monitoring and control of water parameters. And then the second one is to assess the effectiveness of the water lattice used as the biofilter in maintaining the water quality. And then the third one is to develop a dashboard for visualizing the collected data, which will enable efficient management of the aquaponics system. And then finally, to analyze the overall sustainability of this system and for optimum efficiency of the smart aquaponics system compared to the traditional setup. Okay. So this is the proposed system architecture. So we have the prawn tank, which is equipped with the water sensors and which is also powered by our aquatic system. So aquatic system is from our one of our developed solutions, which provides AI and IoT technology in prawn and water monitoring. So it helps to determine the prawn's biomass monitoring so that we can monitor the prawn's growth and we can also feed them with the correct type of prawn feed. Okay, and then it also connected to the water sensors that records all the water pH, ammonia, and dissolved oxygen. Okay, so the water from this tank, the prawn tank, it will go into the first filter tank. So this is the standard mechanical and biological filter. And then it will go to the second filter tank, which is using the water lattice as the biofilter. So for information, this water lattice can be found in the natural ponds. It is quite toxic if you eat it. Okay, it is also a natural pollutant absorber. Okay, that's why we use it here. So yeah, and then after that, from this, the water will go into the lattice hydroponic system. Okay, so this system will be equipped with the water sensors, which measure all the pH, ammonia, dissolved oxygen, electrical conductivity, and temperature, which is controlled by the microcontrollers. We will also attach the light source as and a camera for recording and monitoring the growth. And then the water will go back into the prawn tank. Okay, so this is the system design. As I mentioned, the prawn aquaculture tank will be put in with our aquatic system for prawn detection as well as for monitoring, which we use the YOLO V8 and segmentation. And then for the hydroponic system, we added the sensors, microcontrollers. We also integrate a camera to monitor the lattice growth for detection, which we plan to develop by using a detection model, YOLO V8 or the YOLO V3. Okay, and then once we collected the data, which are the sensor reading as well as the prawn measurements and the growth stages, we will deploy various machine learning algorithms to develop the predictions for the prawn and the plants. Okay, so of course, as highlighted earlier, presentation, it will not be a one-time deployment. We acknowledge that the AI system would need a vigorous and continuous optimization process, okay, to retrain the model. Okay, next is the project stages. So this is the whole overview of everything. So the first one is the development and installation of a comprehensive layout of the aquaponic system. And then the second one is the programming of the microcontroller, and then followed by the IoT integration and development of a user-friendly dashboard. And then number 4 is the data collection and AI model development. So over a period of 6 months, we will gather all the data of the water quality, nutrient, plant growth, even the prawn growth. And then finally, the performance analysis and reporting, which we will be evaluating the effectiveness of this system by comparing its performance with the traditional system. Okay, next one is the impact of the project. So traditional practices, they are not as sustainable and has detrimental effects on the environment, such as nutrient runoff and soil erosion. So this project has the potential to minimize the environmental impact. And then the next one is the integration of AI and IoT technologies can help improving and monitoring predictive capabilities, and therefore enhancing the overall farm operations and system performance. And then finally, with better farming performance, a smart aquaponic system has the potential to provide food security, okay? And the system can be implemented even in urban areas. Okay, so this is the output or outcome. This is the preliminary result. We actually did this pilot study of the water quality. So we compared the traditional recirculating aquaculture system, or the RAS system, and also the aquaponic. So where we initially focused on comparing the water quality and prawn survivability. Okay, we found out that the aquaponic system is much better in filtering the water. As you can see, we added all the water lettuce. It helps to clean up the water. If you can see over there, it's much more cleaner in the aquaponic system. Okay, and for the prawn survivability, there is a 60% survival rate of the prawn in the aquaponic system compared to the RAS system. And that is why our next step is to deploy the mentioned proposed smart aquaponic setup to further optimize the system. Okay, so for the output, we aim to have, the first one is an IoT-enabled monitoring system that can continuously monitor all the water quality parameters in real time, providing data that can be accessed remotely by the farmers. Yeah, and then the second one is the predictive analytic model. We will like to develop the AI models capable of predicting all the fish growth rates, the water quality changes, and the optimal feeding schedules based on the real-time data. And then finally producing research papers based on the results. Yeah. And then the main outcomes include improved water quality management, because with the implementation of the IoT sensors, it will help facilitate real-time monitoring of critical water quality parameters, which will allow the farmers to intercept if there is a problem or if there is some water quality imbalance. And then the second one, to have increased productivity. And the third one, to promote sustainable practices by demonstrating how IoT and AI technology can minimize resource waste, enhance water quality, and reduce all the environmental impacts. Okay, so as a summary, the primary target of this project is to improve the sustainability of aquaponic system through integration of IoT and predictive AI technology. So this involves optimizing the water quality management, resource efficiency, and overall productivity. And then how do we do it? It is by implementing the IoT system that allows for continuous monitoring of the water parameters. And then we will develop the AI model that can predict the prawn growth, water quality fluctuations, and of course, the plant growth again, which will help the farmers make informed decisions. And then this has the potential to promote awareness and sustainable aquaculture practices among farmers and the community, and to encourage adoption of the eco-friendly farming methods that will benefit both the environment as well as the society. And then, of course, which also helps us to improve the efficiency and productivity in the aquaponic system, which can lead to economic benefits and increase profitability. Okay, and so we would like to collaborate with our regional experts in AI, predictive analytics, as well as IoT, to hopefully make this project success. Thank you, everyone.
Okay, thank you very much. Can we have some questions for Ms. Tashin? There, okay.
I am interested in this project very much. I think it's very good to have this kind of system for aquaponic. Do you see, is there any challenge that you find in this project, or the gap that you wish to have, to find the collaboration that would require other people to join your work? Yeah.
Yes, very good question, because I would like to also add on something that is missing from the slide, particularly this part, yeah, this one. Okay, so as you can see, this is the prawn tank. We use the prawn usually the aquaponic system is, they use the tilapia fish. So tilapia, that has a lot of waste, which has a lot of nitrogen. But compared to the prawn tank, it has relatively low nutrient. So we might foresee some nutrient deficiency, especially for the plants. So that's where we need the research in, because we needed to add on more nutrient for the plants. And then we wanted to recirculate back the water from the plants into the prawn tank. So that's I would say that's the gap that we are trying to solve here. Yeah.
Other questions from the floor? If not, again, thank you very much. Let's give her another round of applause. Thank you so much. And last and definitely not the least, all right, from Telkom University, Indonesia, Dr. Koirul.
Bismillahirrahmanirrahim. Okay, good afternoon, everybody. Good evening, sorry. So, thank you very much for being patient in this room. Thank also to the chair and also to the committee who give me this chance for making presentation about the development of security and resilience for 6G potential cryptography based on quantum key distribution and quantum error correction. I do hope that this proposal, it is expected that we can increase the knowledge and also contribution of quantum technology from the ASEAN countries. And then to all of you who are not familiar with the quantum technology, I think you don't need to remember all the equations we present, but at least I do hope that we can also take some insight and also can be of our collaborators. I am Khairul Anwar. My background is on information theory, specifically classical and quantum information theory and coding theory. And okay, so as everybody can see from this figure that this is the support from our lab and the Center of Excellence for Advanced Intelligent Communications in Telkom University, and also beyond 5.5G laboratory, and also the Center of Quantum Technology 2.0. This is a collaboration with Institute Technology Bandung and also with the Indonesia National Research and Innovation Agency, or BRIN, and also, of course, with the support of Telkom University. Okay, so I wrote here the 3 points for the background. So the first is the current telecommunication generations is currently going toward the 5G advance. The standard of 5G advance will be in next year, 2025. And also the 6G will be released in maybe in 2028. And then the commercial will be in 2030. So I think it is a good time for us to move to this technology. And also the second point is that in June this year, the United Nations proclaimed that 2025 as the International Year of Quantum Science and Technology, which we call IYQ. So I think it is also a good time for us that next year will be the celebration of the International Quantum Year. And then when we compare with the classical technology, many future possible applications are possible with quantum technology, and it is not supported by the classical technology. So the target of this project is to continue the development of our project in the previous year, supported also by this ASEAN IVO, which we call PatriotNet. We would like to improve that technology into the use of 5G Advanced and also 6G. And then we are also expecting that to provide conference paper about 3 and also patent 2 patents, and also the journal publication, it is about 3. So everybody can see here from this figure that with quantum technology, we may have another benefit, another benefit of this large number of the coding rate. And then this is the roadmap of the quantum technology for 6G. So this figure also explain that in 2025 we will be having the 5G Advanced, and then starting from 2028 we will be having the 6G. And then I do hope that we can obtain the funding from the ASEAN IVO for the year of specifically 2025 until at least 2026 or 2027. And then this is our roadmap for the development of this technology. So we started this research in 2022 with the funding from the Indonesia BRIN. So we finished the quantum error correction code with 5 qubit and also with 12 qubits, and also we finished the quantum machine learning. And then in 2023, we finished the quantum key distribution with BB84. In 2024, this year, we completed the QKD with E91 protocol, and also the quantum machine learning with higher order modulations. So we are expecting that starting from the next year, we will be receive the funding from the ASEAN IVO. We are expecting until 2027 or 2028 until the start of the standardization of the 6G. And then, okay, so everybody can see that this is the figure from the ITU. This is already formal, the capability of 6G and also the usage scenario of 6G. So the 6G will be having the blue part. This is the new capability of 6G, while the green part, this is extension from the 5G. While for the wheel diagram at the right-hand side, this is the usage scenario of 6G, which is we will be having the 3 new additional points, that is the integrated sensing and communication, integrated AI and communications, and also the ubiquitous connectivity. So from this figure, we are expecting that we make the clear difference. What is the difference between 5G and then 5G Advanced and also the 6G? So when we compare the 5G Advanced and 6G, we will be having the quantum, not quantum, this is the artificial intelligence at the base station and also the core network. And then when we go to the 6G, and then we have the new additional channel, which is the dotted red line here. This is the quantum channel to transmit the key, or we call the quantum key distributions. So this will be connecting the base station to the core, and then also the help with the satellite to cover more larger areas. And then in this part, this is the possible new technology that we can develop for the 6G networks. And then because I put the title on cryptography or security, then I would like to explain 2 points here. So the first, almost all the current cryptography is broken due to the SOR algorithm of the quantum SOR algorithm, while only the remaining some cryptography is still safe. Maybe, but we do believe that this will be also broken in the future with the development of the quantum algorithm. And then from this figure, we can see that the SOR algorithm can break the 1024 bit of the RSA within 0.01 second, while the brute force approach will require 4 times 10 to 134 years to break that cryptography. So what is important from this research is that if we try to develop for the satellite, because the lifetime of the satellite is very long, so I think we should design this carefully before we launch the satellite, because once we launch, and then it is also difficult to update. And then from this slide, it is also important for us to note that the World Economic Forum has decided that the year after 2030 will be the danger zone. So it is very good for us in ASEAN that starting from next year, we are trying to migrate to the post-quantum cryptography or just go directly to the quantum cryptography. And then in this project, and this is our dream, that we can make the experiment connecting the Telkom University and also the Bandung Institute of Technology and also the BRIN. It is represented by LIPI here to test at least the 2 protocol, which is the BB84 and also E91 quantum cryptography. And then these are the possible quantum cryptography that we can test in this project. So for the number 1 and number 2, we completed. But this is the remaining technique that I think we need the future improvement and also investigation in this ASEAN. And then I think I can skip this one. This is the error in quantum domain, which is not available in the classical. So this needs the treatment for this new technology. And then we have developed new error correction code, which we call the smallest perfect quantum accumulate code. And we found that the performance of the proposed code matches with the theoretical performance. So what we need here is the practical experiment later. And then the challenge in the future is that, okay, so this is the viral paper last month that the Google Quantum AI published this paper. This is the quantum surface code, and they completed with distance of 5 and also 7. So their challenge is with the distance of 27, with the total number of more than 1,400 qubits to achieve the bit error rate of 10 to minus 6. So this is actually very challenging. And then this is my plan in this project to invite everybody here. So in the work package 1, this is coordination. Work package 2 is QKD development. Work package 3 is the quantum Marron algorithm until work package 5. And then work package 6, this will be the lab experiment. So we are expecting that we can collaborate with many countries in ASEAN, including Japan. And finally, work package 7 is the dissemination and workshop. So as the conclusions, quantum technology is emerging technology that provides many aspects which are unavailable in the classical technology. And in the proposed project, we propose to improve the upgrade to 6G and also contribution to QKD and also quantum error correction code, which is surface code and non-surface code, and also the quantum machine learning for higher order modulations. And we invite contribution and collaboration with everybody. So again, thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Questions from the floor? There, at the back.
Okay, your presentation is really nice and interesting. So I would like to ask you about, and now how many qubits can you generate for your system?
Okay, yes, this is a very good question. So currently, because we are using the classical computer, so the classical computer can run maximum 13 qubits. So to run more than that, we need the real quantum computer or If it is available in ASEAN, we are very happy. If not, and then we should borrow from other country like USA or UK, for example, to run more larger number of bits. But before doing that experiment using the original quantum computer, I think we need to understand how the algorithm and what we propose. Yeah, so thank you very much.
Yeah.
There.
Thank you for the interesting. So the question is, why do you need so a lot of qubits for the quantum AI? Because just now I think it's a machine we need to unstable. We have a lot of the qubits. What do you think? Because so I saw in the slide you need a quantum machine, a lot of qubits. Yes, okay.
This one, yeah.
Just 1, 4, and 5, 7 qubit.
Yeah, okay, so.
I think it's not real.
Yeah, thank you very much. So this is about the quantum error correction code. Why we need the quantum error correction code? Because the qubit is vulnerable to error. They are very easy to get error, and the error is not only one like in classical, but we have the 3 possible error. So that's the first motivation. And the second is when we increase the distance, and then the probability to make correction is very high. And then to reach the bit error rate of 10 to minus 6, this is also the target of 6G, then we need a big number of qubit because we need the ancilla qubit to protect the information qubit. Yeah, thank you very much.
All right, one last
Yes.
question.
Thank you for the presentation. I'm surprised how you can realize the system with the current technologies. Is there any platform for simulation or for demonstration, the concept?
Yes, okay, so thank you very much. Currently, we use the principle of the famous proverb. So in Indonesia, we have the kalau tidak ada rotan, akar pun jadi. If we don't have ratan, and then the wood or the root will do. So what we can do now is we make simulation with the classical computer and also server. Yeah, so maximum this is until 13 qubit currently what we can do. But with 13 qubit, we try to find the pattern that maybe from that algorithm we can scale up. So once it is possible, and then we should test in the real computer. And currently maybe we can also borrow the computer from IBM, for example, because IBM also give the free access, but in very short, maybe even 5 minutes, this is actually very long for the quantum domain. So by doing that, we can test our algorithm next time. So first, we should contribute even very small, this is our principle. And the second, before we test in the real computer, real quantum computer, we should understand how it works and what is our purpose or what is our algorithm. I do hope that it answered your question. Thank you.
All right, so thank you, Dr. Anwar. So let's give him another round of applause. That concludes the last session of today. So to close this long day, let me call on Dr. Yano Hiroyuki. Sir.